Let's talk about accessing files a little bit. We're going to see some practical use of this very shortly when we start taking in some information from the web. But I want you to be familiar with file access and file handles and file pointers and things like that before we get there. When you are going to access files, no matter the operating system, you're using in the plain C language and you're not using special operating system calls, you're just using the standard library, you will be using things called file handles or file pointers. And file handles have a type of file. Now we know through typedef that there really isn't anything called a file, and it's also in uppercase, so that leads us to believe that it's a type definition someplace else in the header file, and in standardio.h actually is where it's defined. But a file handle is really a pointer to a file structure that's also defined in standardio.h, and I'll show you where that is in just a second. You use a couple of different functions to go against files. fopen is used to open a file, whether it exists or not, a new or an old file. It will create a file if you open one that does not exist and you've told it that's what you want to do. Or fopen can be written in such a way as to open an existing file just for reading, for writing, for both, or appending to the file. So it opens it and it prepares you to be able to write onto the end of the file. Fclose is what we use to close the file handle and release the buffers, and very important to flush information out of the buffers onto the file system so that it gets closed and written to disk properly. getC and putC are common functions used for character I/O against files, reading data and putting it back out. And they're the same ones that are underneath what we've been using with getChar and putChar, because getChar is really just a getC from the standard in, and putChar is a putC to the standard out. So those are defined that way again in standard I/O. fscanf and fprintf work just like the printf and scanf that we've already read about, and they still use the percent formatting rules just like printf and scanf. Here's the file structure defined. This is what it looks like inside standardio.h. We say if not defined, remember that, if ndef, file defined. So if file has not yet been defined, here's how we define it. We create a struct IO buff. This is an IO buffer, and this has also been predefined based on the operating system. But we make a struct IO buff, and there's a character pointer and base and where our flags are located and the buffers and all sorts of things that hide behind our file pointer. And then we do a type def of this struct IO buff of file. So when we use the word file, what we're really creating is one of these things, and we're actually going to create a pointer to one of these IO buff structures to be able to do input and output. And then we define file defined, so if we ever include standardio.h again, it will skip over this, and we won't keep creating this over and over and redefining, and then that's the endif. So see, this is a real use of those preprocessor directives that we looked at a few videos ago. Now here's how you create a file pointer in C. File in uppercase, that's important, little white space, star FP. So FP is going to be a variable that is a pointer of type file, and that creates our file pointer. Now it doesn't point to anything yet. You get it assigned by doing this. FP equals fopen. Fopen, if it can find this file name, we've done it for read, so it has to already exist. If we did it for write, we could have it create the file, and that's a W down there you see in the next line. That creates for write. But if we try to read this file, it will return a file pointer to FP. If fopen returns a null to FP, so FP is set to null after this call, then it did not work. And you'll see that when we do some error checking on opening files for reading and writing. I always check to see if FP is null, and if it is, we have a problem. Now here is opening a file for write, and we just put a W there, and there's a series of different flags there that we'll see as we use this more. They're pretty simple, RWA for append, and so on. And then when you're finished using a file pointer that you've created, you close it. You do an fclose fp, and that does what it's supposed to do. It closes up the file, and more importantly, it writes the data that is laying in memory in the file buffer. It writes it out to disk and closes off the file and makes sure that the data is tucked away properly. Okay, so that's the beginnings of file access. Like I said, we're going to see more of that because we're going to take some data from a web page and we're going to tuck it away in a file. So we'll have to open and close the files and then be able to read them back out again here very shortly. So hang in there.